Hello, welcome back to Blender Sushi Live Noding. In this episode, I'm gonna play around with Sonic Pi and Blender OS C message again. But this time I will be using Blender game engine, and it will be involving also Sverchok and Animation Nodes. So a lot of interesting mechanics behind it. Hopefully this is works correctly as I'm recording. So basically, let me restart Sonic Pi. So I have this little program inside Sonic Pi currently running. So this Sonic Pi is listening to OSC message from the outside, so I can use any kind of app and I can basically send message to Sonic Pi through this address. So the setup is very simple, just play synth on a time basis. And here on Blender, inside Blender, I have Blender game engine ready to start doing something. So if I just hit P, so this guy is actually playing and triggering sound based on collision. So that's actually what's happening. So I have this like a pole, like a cylinder, and I have this kind of a random looking objects that's spinning. And based on whenever it touches the pole, it's gonna generate random frequency synth based on this little Python code. So yeah, the setup is that simple. And if I play it back, and let me quickly change to different synth. I like number 16. That's really nice. So that's the noise. And let me try number 4. Oops. Okay, here. So basically I have a list of synth here, like a list of string here that I can use down here using the index, whatever index. If I change it and then I run the Blender game engine, it's gonna generate synth based on that choice of synth name. Okay, maybe I'll do a quick breakdown of the node setup in Sverchok and Animation Nodes. So for Animation Nodes here, I didn't do much. Really, I just have a way to generate more poles. If I try running this, hopefully it doesn't crash. So you can see there are a lot more pole, and that will trigger sound. And okay, apparently runtime error. Too many message coming into OSC, but into Sonic Pi. If I'm not recording, this is like 20 times faster. So I'll run it again. So now Sonic Pi is listening to OSC data, playback, and supposedly it's working. Okay, this one, oh, okay, I know. Apparently I have a wrong name, something like that. B noise, chip bass. Okay, restart, playback. Thread got too far behind. So yeah, apparently there's a slowdown happening again. Yeah, unfortunately my computer is not fast enough to run all this, but you can see there are two objects, this guy and this guy, the pole, and this weird thing over here that I actually can change using Sverchok. See, this is the interesting part. I can randomize how this like 0 and 1 of the thingy. If I turn it off, it's just gonna generate this kind of flower looking shapes. But if I'm using my own list input, like on and off, let's say I am generating something like that, and then I turn on sum, this will generate these three things. And so you can see the hit on the top left there. Whenever it hits, it sends a message to Sonic Pi, and generate a sound. Let me try again. Hopefully this is work now. I'm only like, I have like 1, 2, 3. So 3 message got sent since my computer is a bit slow. So let me try using a different one. Piano, for example, piano. Just instead of doing this, I just type in piano or pluck, and let Sonic Pi sleep a little bit longer or a little bit less, maybe a little bit longer. Play it back. 1, 2, 3. So supposedly it makes 3 sounds there. 1. So message coming in. Yeah, it's running really slow, so it's not real time, but it's actually running in real time. And I could generate more of this guy. So ideally, this can be used to generate like a sample, like a drum beats or things like that. This is actually too many. Maybe like we have 17, maybe just 8. 8 is good. So here also 8, and I can turn on and off this thing. So now it's whenever now it's almost in real time. So 1, 2, 3, 4. That's not too bad. And I can make this maybe smaller value. 1, 2, 3, 4. Yeah, it's random. It's just random frequency. You can see here. And now it seems to be slowing down again. Yeah, it's rather quite interesting. But ideally, this will be like real time. If I'm not recording, this is real time. And what's really interesting here is some kind of a setup that you can create, kind of simulating like a music box. And if you are also ever watched this YouTube channel called Wintergatan, I think he's somewhere in Netherlands. Wintergatan. He made some kind of music using really weird instruments like a metal balls and wooden, like a rotating wooden thing. This is kind of like, I was inspired by what he's doing. I'm trying to recreate it using Blender. Blender game engine is perfect for this because it should deliver like a real-time performance. So all I need to do, ideally, this is like, you can imagine this is like if this is a music box, this is a one frequency that should be played at a certain time. And using Sverchok, I could actually generate more of this guy. Like if I actually make more of this, they should actually rotate. Yeah, maybe I shouldn't do that because it's too slow already, but I could say if I'm using animation nodes again and generate more of this cylinder pole, and then I could randomize it. This will generate and trigger more sounds and noise. You can see it from the hit points there. And yeah, it's probably too hard for my computer right now, but yeah, that's basically the idea. The game engine setup itself is very simple. The nice thing about game engine is that there is this logic. The logic editor is almost like a nodes. You are dealing with sensor, controller, and actuator, like a three kind of node blocks there. It's very pretty robust actually once you know how to do it. And here I'm my little small Python code actually just using the built-in collision system, and Also, the rotation is coming from this. The simple motion, the rotations is made simply by using these nodes, and it's calculated as always. And this guy has this hit property that whenever it's being touched, it's gonna increase the attribute up here. See, I turn on this guy right here, and then make sure also to turn on the show debug properties. So now if I'm running this, it should run the program and the synth. Well, I can always change it here actually, like, because the cool thing about Sonic Pi is that like this guy is also like a real time. You can change and make any changes to this guy, and then it will update into the live loop, and the music will change. Well, this is probably too heavy. Turn this one back to 1. So now we have this. Let's try Zawa. Zawa is interesting sound. Run the program. Hit P. It doesn't sound like Zawa, but maybe it is. Yeah, that's Zawa. Zawa is more like. Yeah, it's too slow on my computer to run it in real time, but this is actually much faster if I'm not recording. Anyhow, that's the whole process. So there's a lot of thing going on, but the mechanic is all there, and it's quite interesting. You need to have Sonic Pi, and you need to have Blender, and we are using Blender game engine, and everything happens in real time except for the modeling of this guy and then the position of this cylinder. It's I think quite interesting. I don't know how you can actually use this kind of setup. Definitely we can have something very interesting happening. It's like you're not making a game. It's more like a kind of like interactive. It's almost like an app, and so the real time is the key point here, and you generate sound, and then you can also trigger animation this way, and then there's much more freedom. And also you have music as a bonus, so visualization, music, and then a little bit of codes, and then yeah, it's quite interesting. So yeah, I guess hopefully you'll find this interesting, and let me know what you think, and I'll see you next time. Thank you. Bye.